Now you have to understand law of conservation of energy. Energy can neither be created nor be destroyed, but it can be transformed from one form to another. That means total amount of energy in the universe remains constant. So this is your law of conservation of energy. How will you prove law of conservation of energy? For this there is a small activity. You have to take a thread and take two nuts of equal size, tie them with two knots with the same thread in such a position that they are not touching or hitting each other while swinging. So this arrangement is known as coupled oscillators. Okay. Now what you will do? First you will take the nut 1 in your hand, okay, and swing it, okay. The moment you take the nut in your hand and release it, it will start swinging on its own. When this nut N1 will stop, you will find that nut N2 will start swinging on its own. How it has happened? The energy from nut 1 N1 has transferred to the nut N2. Okay? This example helps you to understand that energy can get transformed from one form or from one place to another place. Let us understand law of conservation of energy through this example. When this object is falling down, it is under the effect of Earth's gravitational force totally, and it is known as free fall. Okay? Or a free falling body. So, when a free falling body is falling from a height, we can consider three positions of the object. Suppose I have taken a ball of mass m and kept it on a top of the table. So, it is at a position A and it is at a height h. When the ball falls down, I catches it at position B. During this time, it is covering a distance of x. Okay? When the ball falls down, this is on the ground. The ball is falling down on the ground. It is position C. So, we can consider the three positions of the object at position A, that is on the top of the table, at position B in between, and at position C on the ground. We have to calculate kinetic energy, potential energy and total energy in these three different positions. Now, at position A, when the ball is at position A, the initial velocity is 0 meter per second. We know the formula. Kinetic energy of an object is half into mass into velocity, which is u, mu square. Now here u is 0, so if we substitute, we get half into m into 0, that is kinetic energy is 0 at position A. But during this position, due to its position, it is having potential energy. Okay? Potential energy, we have seen the expression for potential energy mgh due to the height h. Okay? Now, if we find total energy at position A, we will get kinetic energy plus potential energy. which is 0 plus mgh. So total energy at position A is mgh. This you can consider as equation 1. Got it? You have understood this? Now we have to calculate the total energy at position B. So here at position B, the object is coming with a velocity. So we can consider the velocity at position B as VB. Okay, velocity at position B. This time its initial velocity is 0. Okay, the distance which it is covering, that is s, is equals to x, and it is coming under the force of gravitation. So acceleration is acceleration due to gravity, that is A is equals to g. When the object is coming at a position of B, by using Newton's third kinematical equation, we can say V square is equals to U square plus 2AS. Now V is the velocity when it is coming to position B. So we will write VB the square is equals to U is 0. So this becomes 0. 2 into A is your G and S is your X. So VB square is equals to 2gx. But kinetic energy at position B is half mvb square. Okay, but we have got the value for velocity at position B, 2gx. So we can substitute. So we will get kinetic energy is equals to half into L into 2gx. This 2 and this 2 get cancelled. So kinetic energy is equals to mgx at position B. Now at position B, it is having potential energy also. So we have to calculate potential energy. But this time the height of the object is h minus x. So potential energy is due to the height. So we have to consider this height. Okay. So potential energy, we know the formula mgh. But for height I will write h minus x. Okay, when we open the bracket, we get potential energy is equals to mgh minus mgx. Okay, multiply here and multiply x. Now we can find out total energy. Total energy is kinetic energy plus the potential energy. Kinetic energy was mgx plus mgh minus mgx. Due to opposite sign, it gets cancelled. So total energy here at position B is mgh. This is equation 2. The first equation, total energy is equals to mgh. Second equation also we have got total energy is equals to mgh. Now what will happen when the object falls down at position C? At position C, we can consider the velocity on the ground, the velocity here we can consider Vc. Now, initial velocity of the object is again 0. The height, the displacement covered when it is falling on the ground is h, and acceleration is acceleration due to gravity. Now again we have to use using third kinematical equation. We get v square is equals to u square plus 2as. This is the formula. Substitute in this formula. For v we will write velocity at position c square is equals to u is 0, 0 square plus 2 into g into height s is h. So here vc square is equals to 2gh. Now when the object is falling on the ground, what is the kinetic energy? Kinetic energy formula half mvc square. We can substitute this. We get kinetic energy is equals to half into m into 2gh. 2 and 2 get cancelled. So kinetic energy is equals to mgh. So when the object falls on the ground, the kinetic energy is mgh. So what about potential energy? When the object falls on the ground, the distance or the height covered at position C is 0. So at position C, the height covered by the object is 0. So we can write potential energy is m into g into 0, that is equals to 0. Now total energy is kinetic energy plus potential energy, that is mgh. This is equation 3. For your equation 1, we got total energy mgh, equation 2 total energy mgh, and equation 3 total energy is mgh. What does this mean? That when an object is freely falling on the ground, the total potential energy which is stored in the object slowly gets converted into kinetic energy, and the energy remains constant at all the positions. This satisfies the law of conservation of energy during a free fall. Okay, you have to remember this, that how you will prove law of conservation of energy during free fall. So you have to write it down. Okay.